The magnification of an image is a measure of how large an image is compared to an object. We can produce images like this using a lens. The lens will refract light from an object so that it can converge on a screen to form a real image. Alternatively, light can diverge and form a virtual image when we look through the lens. For this image, we can see that it is much larger than the object. The light rays from different points on the object converge further apart from each other in the image, so the image appears to be larger. The magnification is then a measure of how much larger the image will be. We could also measure the magnification of an image like this. We've used a different lens to produce an image that is much smaller than the object. The magnification is then a measure of how much smaller the image is compared to the object. But do we need to actually form the image to determine what the magnification is? Well, the magnification of an image can be deduced from the height of the object and the image on a ray diagram. Remember that we can use a ray diagram to show how light rays from an object pass through a lens and then converge to form an image. We start with an arrow representing the type of lens we're using, and then the principal axis through its centre. We then draw an arrow from the principal axis to represent an object. This arrow tells us where the object is and its height. The image will then also be represented as an arrow, and we can compare the two to determine the magnification. For example, if this arrow represents the image formed, then we can see that it is much smaller than the arrow for the object. This tells us that the lens has formed an image that is smaller than the object. We can refer to this as a diminished image. On the other hand, if the image is represented by an arrow that is larger than the arrow for the object, then this tells us that the lens has formed an image that is larger than the object. We can refer to this as a magnified image. Now, don't get this term confused with magnification, though. Magnification is a measure we apply to both larger and smaller images, while magnified is a way of specifically describing a larger image. Remember that these arrows represent images and objects. So if this is the object, then the images would look something like this. For your exam, though, you only need to be able to recognise when an image is larger or smaller than the object based on the heights of arrows in a ray diagram. Now let's go through the different situations that form either diminished or magnified images. Real images from convex lenses are diminished if the object is more than 2 focal lengths away from the lens. Now remember that a convex lens curves outwards. We represent this in a ray diagram with a double outwards arrow like this. The principal axis is then the line along which a light ray won't refract. Rays parallel to this line will converge at a point called a focus. The distance from the lens to one of these points is called the focal length. Let's construct the ray diagram for an object placed here. As we can see, it is more than 2 focal lengths away from the lens. To construct the diagram, we draw 3 key rays. Firstly, the ray that passes through the centre of the lens will continue in the same direction. Then a ray parallel to the principal axis will pass through the focus on the other side. Finally, a ray through the focus on this side will be parallel to the principal axis after refracting. The image then forms where these rays cross here. So we draw an arrow from the principal axis to this point to represent the image. As we can see, the arrow is shorter than the arrow for the object. So this is a diminished image. Cameras and our eyes will use lenses in this way to create small images of large objects. Real images from convex lenses are magnified if the object is between 1 and 2 focal lengths away from the lens. Now let's suppose the object is here. further than one focal length but not as far as two focal lengths from the lens. Now when we draw the rays, we see that they converge at a point lower down. So this will be the arrow for the image. As we can see, it is longer than the object arrow. So this represents a magnified image. This setup will be used for projectors, which take a small scene on a film and turn it into a large image on a screen. Virtual images from convex lenses are always magnified. So far we've been looking at real images, which form on the other side of a lens and can be viewed on a screen. But lenses can also form virtual images, which will be on the same side of the lens as an object. This is because light rays appear to converge if we look through the lens, making us see an image. A virtual image can be formed from a convex lens by placing an object between the lens and its focus, such as here. Now the object is less than one focal length away from the lens. To construct the ray diagram, we still draw a ray through the centre of the lens, and then parallel to the principal axis through the focus. Now these are the only two rays we draw for this case. To find the image, we need to trace the rays back to before the lens to see that they appear to converge here. So this will be our image arrow. It's taller than the object arrow, so this is a magnified image. You'll most often see lenses used in this way with magnifying glasses, where we create large images of objects by looking at them closely through the lens. Virtual images from concave lenses are always diminished. A concave lens is a type of lens which curves inwards. We represent it on a ray diagram using a double arrow pointing inwards. This lens will cause rays parallel to the principal axis to diverge, but appear to converge at the focus on the same side. Now let's construct the ray diagram for an object placed here, pretty far from the lens. Like the previous diagram, we only draw two rays to find the virtual image. First, a ray straight through the centre of the lens, and then a ray parallel to the principal axis, which then diverges upwards. If we trace this ray back though, it will pass through the focus on this side of the lens. Again, the image forms where the lines cross, so this will be the arrow for the image. It's much smaller than the object arrow, meaning it represents a diminished image. No matter where the object is, the image produced by the concave lens will be smaller than the object. This makes this lens useful for telescopes, which makes distant large objects appear smaller. Now it's helpful to remember how each type of lens affects the size of an image and under what circumstances. So let's fill in this table of the different cases we've looked at. For a convex lens, when the object was placed between the lens and the focus, we created a large virtual image. So this is a magnified image. When the image was further away, between 1 and 2 focal lengths, the image was real and large, also a magnified image. For faraway objects though, more than 2 focal lengths from the lens, the real image formed was very small, so it was a diminished image. The column for concave lenses is much easier to fill. No matter where the object is, the image was always diminished. Now, although this table is useful, you won't need to memorize it for your exam. What's important is that you can demonstrate each of these types of image forming in these cases using a ray diagram.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!